Okay, let's start. So, my name is Mikael Latvala, and I'm going to briefly talk about the EcoApartment pilot that is done under the IoT program. And partners in this project are Aalto University, University of Tampere, VTT, and Tere Corporation. So this is pilot project together with these partners. Briefly about the Tere Corporation. Actually, enough from this slide is to say that we are a startup company established 2009, and our mission is to make money, or otherwise we will die. And this is more or less from that aspect that I will go through this presentation. So, the motivation. All you know about the emissions and that we are supposed to cut down the emissions. And this is the one estimate what would happen if we will continue using the energy the way that we do today. That's the upper line. And if we want to reach those reduction goals that are set by European Commission and other international organizations, you see that we have to do lots of different things there. But the most interesting thing in this picture is that the biggest way to reach those goals is not by generating new ways to create energy, but to save energy. And when you hear people talking about, how do we reach these goals, almost always the discussion is that we should use solar panels and wind power and so forth, and nobody talks about the savings. So our mission and in this pilot is to really try to find ways how people will start saving in the energy. And we won't focus on how the energy is actually produced. So we had this idea that those who the IoT field know this term triple play, where you have the voice, internet, and TV. We have the ecological triple play, where we have the water, electricity, and the heat. And the idea there is that by monitoring the consumptions of these three different things, people eventually will start saving in the energy consumption. Now, the business case. Most of the people in cities live in apartment buildings. Those who live in apartment buildings, and more those people are these rather young, some of them call themselves hipsters, environmentally conscious people. And the good thing about that is that they are willing to make an investment on technology where you don't necessarily immediately calculate the revenue of investment. Rather, they're willing to invest on something that will hopefully make this world a better place to live. Now, on the other hand, we have been on a market of selling also energy-saving solutions for the homeowners. And that's not necessarily the case, because homeowners mainly are interested in investments where they can see the revenue of investment. But with the apartment building dwellers, that's not the case. So there is a big difference there. Now, so we have found the need for the place where we could provide the solution. Now the challenge is to make this monitoring interesting. So nobody will go there after a hard day of work. The first thing in their mind is definitely not to run to the monitor and see how much energy they have used or how much energy they're using currently. And the gamification is the big word here. So eventually we have to provide different incentives in forms of different game level strategies, how people will come back. And also the idea is that you will start comparing your own behavior against your apartment, other people living in the same apartment building. And in the end, most of the studies say that the energy savings can be up to 15%. So here's the business case for this pilot, and it's looking pretty good, I would say. From the actors, these are rather self-evident, but the interesting part there is the facility manager. Now, facility manager in many countries is the one which actually runs the apartment building, and if the solution could be such that, for example, it's the white label solution, and facility manager actually then will integrate this solution to their own customer portfolio, because nowadays most of the facility managers have their own portfolio for the apartment building, the people living in the apartments. So the apartment owners can see, for example, information about the apartments, and also they can monitor some things. But to monitor the water, electricity, and the heat is not possible currently. So you could easily provide this as a white label solution for the facility managers. High-level requirements. Obviously, the system must be inexpensive. Even though I say that the people who are willing to make investment on this, who are not interested in the revenue of interest, obviously that does not mean that the system can cost anything. So there must be some upper limit. So naturally, what today you want to do, and especially when you're a small startup, is that you don't want to start building your own data farm. So you're going to put the most of the data repository should be definitely in the cloud, which is inexpensive, scalable, and robust. Software as a service. So this is the thing that I talked earlier about the games. So we have to make sure that we involve different social media technologies so that we get people come back and learn more and get interested in the data. Then from the communication point of view, because these are existing buildings, we should use as much wireless communication as possible. Then I will show you later on, we have some real-life examples that this is not always possible, but whenever possible, that's the way you should go. And connect to IP when it is feasible, not as early as possible, but whenever it's feasible. So many in this program today and this week and elsewhere in the world, they talk about the IP to the smallest sensor. And I say that, definitely today that does not make sense from the business point of view, because still the technology is too expensive. And IP, that I mean IP technology. Also another thing that we have learned the hard way is that if these sensors that we will use have batteries, there's definitely a big maintenance burden. Imagine an apartment building with 100 apartments, and when the battery starts expiring, the manager will run there almost every second day, eventually. So, and then is somebody there at home? Are the keys there, and so on? There are lots of problems. So this is definitely something you should take into consideration. So when it comes down to measuring the electricity, on the left-hand side, we see this so-called smart meter. Most of the smart meters, fortunately, have blinking, visible LED lamp, which indicates the rate at which you use electricity. Unfortunately, that is not the case with all the electricity meters, but 99% of the cases, fortunately, this is the case. In that 1% case, then you have to find some other interface to the meter. They have some so-called S0 interface, but that is not that well specified, and many times that the utility man has to enable that port before you can access and retrieve data from that. But assuming that there is this blinking LED lamp, then you need this light pulse reader and a concentrator which reads light pulses. And as you can see here, I don't have a pointer, but this Ethernet VLAN one-wire Zigbee text indicates that how should the communication happen between the light pulse reader and concentrator. And that is exactly the most crucial place. For example, do we want to take the IP all the way? And in our current studies, we have said that no, that doesn't make sense, because it will become prohibitively expensive if you take the IP all the way to the end. And then from the concentrator, you go to directly to the data repository, which is in the cloud, and then you can access the data using the mobile device or PC. Now, for the heat and water measurements, it's a little bit different type of a setup. Here, the green box means a single apartment, so the device is within a single apartment. Sometimes the water meter is not in the apartment, but here I assume that it is. So then we would have the need for the whole bunch of different sensors. One is sensing the temperature, one is sensing the flow in the radiator, and then we have the water meter sensor. Then we would need the concentrator, which retrieves the data from these different sensors and concentrates them and sends them to the cloud. And then we have naturally the DSL modem there, which is used typically, or a cable modem, which provides the connectivity to the data repository in the cloud, and the PC mobile node. Now, this is the current target. This is the apartment building built in 1966. It has, there's two similar ones, but we are starting the pilot with the first one. Altogether there are 50 apartment units. And here you can see how the electricity meters are located. They're located in three, closets. I don't call those rooms, they're closets. And they're rather close to each other, but the distances between these closets is rather long, So it's all 40 meters from this end to the other end, and then there's this nasty little curve and lots of concrete walls. So if you use some weak radio like C-Wave or Zigbee, the connectivity issue is definitely there. And definitely it's not going to work even in some of the cases. Like when we try to get the connectivity from this leftmost box to the one here, the signal didn't propagate. So, unfortunately, we even had the fire door here, which is made of sheet metal. So and this is the current setup what we have used in our example. We started with the sensor, then we used the Arduino board, which more or less collects the pulses, light pulses from these individual meters, and so we have one Arduino board per closet. And this Arduino board will then send that over the Ethernet cable to this blue room here. And in that blue room here, we have a Raspberry Pi, which is then connected to the internet. There we have a DSL concentrator, because all the apartments have a DSL cable, DSL technology provided. Actually, it's a DSL to the fiber converter, because the fiber comes to the apartment building. And the idea here is that we try to use the wireless LAN and the C-Wave first, but we have so many connectivity issues. With this wireless LAN, not so many, but the problems were that at times we could not get any connectivity. For some reason, the driver was not very robust, so it went blank, and we had to reboot the boards. So we decided that for the sake of the pilot and to keep the pilot customers happy, we would have to find more reliable solution. For that reason, we selected the Ethernet. And that's actually something that we also learned, that when you get these pilot installations up and running, and you have to get the people living in this place involved, the worst thing there is that the system doesn't work. So, if that happens, they usually say, well, I'm not that interested, and then you have the next big meeting where you discuss whether whether we should continue this. If people are not able to access that, then they say, well, we don't care, we didn't really find it useful. So, cannot really make too many mistakes, serious mistakes in the pilots, even though some people think that pilot means that that's where you can make lots of mistakes. But the serious, really hard-level mistakes where the service is unavailable for many hours, sometimes even days, that is something not acceptable. And the installation, here you can see also, to say what I said verbally. Another big problem what we realized that, it's easy when you draw these images on a PowerPoint slides. But here we just draw this yellow line saying, we assume that there is a connection to the AC power. Well, surprisingly enough, none of these closets have outlets, even though you have a bunch of electricity meters there. And then the question is that if you want to get the electricity, where you get it? You cannot get it from individual apartment bill from the meter, because obviously that is then charging. Then you end up charging for somebody for the whole services that is provided for all of these 9 units. So you have to get the power from somewhere else, and that means that you have to do a lot of drilling and wiring and so on. So that's where the wireless technology would be excellent. Unfortunately, in our case, that did not work. So power over the Ethernet turned out to be the most feasible thing, because also it can feed the power to the closet in addition to the communication line. Unfortunately, the power over Ethernet is not very commonly deployed in many solutions. Another thing that when I said that we have to be expensive is naturally to the cloud service, where you can imagine that if you start providing real-time electricity readings, and that real-time means every 10 seconds, the data volume is huge. And those you who know the Google service, Google wanted to provide this similar service to the customers. They had a limit that you could send meter data only every 6 minutes to Google database. And now you can imagine that Google should be rather scalable. At least we think that Google platform is scalable, and they can accept data only every 6 minutes. So the bottom line here is that the database which stores these time series should be extremely robust and efficient. And we did some, University of Aalto University did some measurements, and a Mongo database, not to the surprise of many people who know a little bit about these databases, turned out to be the best solution. And you can see that Mongo is with the green color. It's clearly outperforming on both on insertion and query values. And query, well, the question is that how much we should put emphasis on the query value. Well, that depends on how much people want to see the data. Naturally, the insertion is the values are true regardless of how much people are interested in, because the data will keep coming. Another big problem that is not issued here is that at one point, you're going to start having lots of data. So you can imagine that, you have 100,000 electricity utility, medium size, small, medium size, has 100,000 customers, and they all send data every 10 seconds. Suddenly you will start having, you will ask, where do I put all this data? And actually, is all the data meaningful after 5 years or so on? So, these expiration things, that, when data expires, that they come into the really big play. And actually, there's another study that Aalto University will start, where you can think about the smart expiration algorithm, where, the data will go away eventually, so that you will not notice that, because usually you're not interested in the events at the 10-second granularity 5 years away from the present time. So the problems that we have been having, like I said, the outlet thing, that the outlets are not available. Another very practical thing is that most of these meter rooms or closets are locked, or all of them are locked, and the keys are only available for the utilities. Even the apartment manager doesn't have the keys typically. So you can just see the problem that when the installation team comes in, they will take few phone calls, probably in a few days before you have the keys. And then what happens if something you have to do, repair, or make sure that if this requires rebooting or whatever, that just the access to the rooms, is rather challenging. Also, the meters, unfortunately, are usually located in the basement area. So, like I said, the fire-safe doors and the wire, and the concrete walls, they are nasty for the wireless signals. So obviously, if it's operating in the below 1 gigahertz band, 800 or even 400 megahertz, that's good news. But as you know, Zigbee, for example, does not operate on in that band. They operate in 2.4 gigahertz. So that's not. The concrete walls are extremely nasty for that frequency. And also the wiring in apartments. I was mentioning that when we go to the apartments, if you base your solution on wires, that means lots of work there, and also people don't like the wires hanging on the wall. So if you cannot hide them, so big objections will definitely rise immediately from the owner's part, and that definitely is not something that will promote this pilot further. Further activities, obviously, some kind of detection signal. So when you go beyond the monitoring, and the big thing is the demand response and local production. Okay, here I said earlier that we are not interested in the local production, but how actually you will inform the people, for example, how much the panels will produce electricity to the apartment company. That's something that probably people are interested in. And abnormal event detection and alarms, And something that we had a discussion with the local utility company, Helsinki Energia. We got one interesting story was that the central heating, or district heating as it's called in Helsinki, most of the Nordic countries have that. That means that there are these huge water pipes, hot water pipes providing hot water to the apartment buildings from the central utility place. And they have a big problem. During the winter time, when people go to shower between 7 and 9 a.m., they cannot provide enough of hot water with their normal the power generating system. So they have to use so-called spare generators. And and they usually run either using gas or fuel. And that costs lots of money. So they would like to have a solution where they can send a signal to the apartments, and they will cut down the amount of hot water for those 2 hours. And so we can shave the peak. So the question is that if the signal comes to the apartment building, then what should happen there? And so this is definitely that comes to play with our system. That could we, for example, provide incentives, information for the people that okay, now the hot water is not going to be. For example, if you take a shower, you should not be there more than 2 minutes or so on. So there are different solutions that we are under discussion right now. Another one is more easier to create and deploy is when you're away or when you're at home, using that, you signal whether the apartment should go to the setback value using the temperature thermostats, or then when it should be in the normal temperature range. Obviously, then the personal adjustment, that's also possible, but that is more like adjusting the central heating control system. So I will not get into that because that's another different story. And that's in brief what we have been doing.